Good morning, class 7th. We start with a new lesson, lesson number 15, light. Let us recall what we have learned in the 6th standard. So, what is light? We all know that we need light to see anything. If it is completely dark, we cannot see. But what is light? Light is a form of energy which does not require any medium to travel. This is the reason why the sun's light travels through the vacuum and reaches the other planets. We also learned that light always travels in a straight line. This we call it as rectilinear propagation of light. Some objects give out light and we call them as luminous objects. Others which do not give out light are called as non-luminous objects. How do we see? We need a light source to see, isn't it? We cannot see in dark. But how do we actually see? When light from a luminous object falls on any substance, it gets reflected in different directions. It means the light bounces back. When this reflected light reaches our eyes, that is how we see. Now let us understand the concept of reflection of light. Have you ever thrown a ball on the ground? What happens to it? It comes back to you. We say that it bounces back, isn't it? It could be a cricket ball, it could be a basketball, it could be a sponge ball, any sort of ball will bounce back, isn't it? So, light, when it falls on a surface, it also bounces back. This is called as reflection of light. So, bouncing back of light in the same medium after getting reflected from a surface is called as reflection of light. Depending on the type of surface that the light falls on, there are two different types of reflection. One is a diffuse reflection or irregular reflection. If light falls on a surface which is not even, which is irregular, the reflection will also be irregular or diffuse. But if light falls on a smooth, plain surface, we will have a regular reflection. Let us see these two pictures showing reflection of light. So what do you see? You see a calm lake which shows the reflection of the trees nearby. And in the second picture, you see a metallic ball showing reflection of a nearby building. So what do you see inside? You see a picture. You see a reflection of some object which is near it. We call this as image. We call this as image. The picture you see as a result of reflection is called an image. So, daily we see our images in a plain mirror while brushing our teeth, while getting ready to school, while combing our hair. We look into a plain mirror. The mirror which is there in your house, we call it a plain mirror. But do you know how a mirror is made or how does it work? It is actually very simple. A mirror is made up of a plain sheet of glass, which is a smooth surface, very, very smooth. On one side, I coat it with a silver paint so that light cannot pass through it but gets reflected back. When I stand in front of such a glass plate with a silver coating on the other side, it becomes a mirror. And what I see in a mirror, I see an image. So, if you are standing in front of a plain mirror, you are the object. You are the object. And the picture you see in the mirror is the image. So, if you place a pencil in front of the mirror, the pencil becomes the object. And the picture that you see inside the mirror of the pencil is its image. Okay. Here are some of the words to describe an image. Erect or inverted. Real or virtual. enlarged, diminished, or of same size. And lateral inversion. Now, what do these words mean? Let us understand these words with the help of pictures. Look at the first picture. Is it familiar? It's a pinhole camera, which you did in class 6, isn't it? So, the pinhole camera is focusing on a tree. And what do you see inside the pinhole camera? You see the image of a tree, which is there on the walls of a pinhole camera, isn't it? So when you obtain an image on a wall or a screen or a paper or a cloth, we call it as a real image. So an image which can be obtained on a screen is called a real image. What about the picture of the tree? Is it okay? No, it is upside down. Such an image is called an inverted image. If it is same as the tree, then we call it as erect. But here it is inverted. Look at the second picture. Here we have a piece of a chess coin, a pawn in front of a mirror. What happens? You see the image inside the mirror. The pawn seems to be coming from inside the mirror. Can you actually obtain this on a screen? No, you cannot. That is why this image is called a virtual image. And see the image, which is just like the object, upright, standing straight. That is why we call it as an erect and virtual image. So in the first picture, in the pinhole camera, you get a real and an inverted image. When you see in a plain mirror, what you get is a virtual and erect image. See the girl seeing her hand in the spherical mirror. Look at the size of the hand. Does it seem big to you? Yes. Here, the image is bigger than the object. That is why we call it as enlarged. Look at the man seeing his reflection in yet another spherical mirror. How do you see? The man looks small. He seems to have shrunk. That is why this image is called as diminished. So the image is larger than the object. We call it as enlarged. If the image is smaller than the object, then we call it as diminished. Now let us understand what is lateral inversion. Look at this basketball player with a ball in his hand standing in front of the mirror. In which hand does he have the ball? He has it in his right hand. But look at the image. Which hand does it seem to have the basketball? It seems to be the left. So what has the mirror done? When you look at the mirror, it has changed the right to left and the left to right. This is nothing but lateral inversion. We see it all the time when we look at the mirror. We just don't realize it. Okay. So in any mirror, if you see, there will be lateral inversion. The right becomes left and the left becomes right. Now, after studying plane mirrors, there is a second category of mirrors called as the spherical mirrors. Okay. So what is a spherical mirror? It is a part of the sphere. Suppose you have a ball. You cut a piece of this ball. And what you get? You get a spherical mirror. Okay. Now based on, you can paint at two different points, isn't it? You can paint the inner side and you can paint the outer side. So based on where you are painting, you'll get a concave mirror or a convex mirror. If you paint the inside, then the reflecting surface becomes the outside. We call it as convex mirror. But if you paint the outside surface, then the reflecting surface or where you stand will be inside of the mirror, isn't it? Then it becomes a concave mirror. Confused? Don't be. I have a very simple solution for you. Have a spoon. Look at these spoons. What do you see? Okay. So the spoon which is tilted, which shows a surface where you actually have the food, is a concave mirror. Okay. And the surface where you cannot hold the food or you mash the food with is the convex mirror. Now look at the images and store this information away for our later use. Can you see the images in these type of mirrors? Now let us understand the type of images formed by a concave mirror. So you can have the object placed at different places from the concave mirror, at different distance from the concave mirror. In that case, you will have different images. But most of the time, the images formed by a concave mirror are real and inverted. But the size keeps changing. It keeps increasing when we take the object near to the mirror. But if look at the last picture. If the object is very near to the mirror, in that case alone you get a virtual and erect image. So how are these concave mirrors useful to us? It's also the doctor's mirror. The eye doctor, your dentist, your ENT doctors, all of them use this mirror only to take a good look at your eyes, your ears, or your teeth. These mirrors are also used as reflectors for headlights in the vehicles and as reflectors for torches and telescopes. They can also be used as makeup and shaving mirrors. And they are also used in solar cookers to gather all the sunlight. The second type of mirror, the convex mirror. Remember the outer surface of the spoon. Okay, that is the shape of the convex mirror. So take a look at the different images that can be formed by placing the object at different positions. So as the picture tells you, wherever you have placed the object, always in case of a convex mirror, you get a virtual, erect and a diminished image. Okay. In case of a convex mirror, it is always a virtual, erect and diminished image. For this purpose, the convex mirrors are a very good choice to be used as the rear view mirrors in your vehicles. Be it your two-wheelers, be it your cars, heavy trucks. In all these vehicles, mirrors are fitted on the sides to tell the driver about all the vehicles which are coming from behind. These are called as the rear view mirrors. Since we always get a diminished, a virtual and an erect image using a convex mirror, these are very useful in knowing what all are the vehicles that are coming behind you. Not only these, convex mirrors can be also used as security mirrors in the staircases, in malls, in shops, etc. Okay, as a kind of a surveillance mirror. Now, have you tried to read very small print? You won't be able to, isn't it? Sometimes on the medicine bottle, the dosage or some things are written so fine that we are unable to see it. What do you do then? There is a glass inside the house. We call it as a magnifying glass, isn't it? You take it out and try to read with it. So what does this magnifying glass have? It is made up of something called as a lens. So what is a lens? A lens is a transparent material which is bound by two surfaces. Okay. So what's the definition of a lens? A lens is a transparent material bound by two surfaces. When these two surfaces happen to be convex surfaces, then we call this lens as a convex lens or a double convex lens or simply a convex lens. When both these surfaces are concave in nature, then we call this lens as a concave lens, a double concave lens or simply a concave lens. Remember, we can also have one plane surface and one convex surface, then the lens will be called a plano-convex. Similarly, one plane and the other surface a concave, then the lens becomes a plano-concave lens. So these are the two types of lenses that we are going to study, the convex lens and the concave lens. Let us see the ray diagram of the convex lens. So what do you see here? The convex lens is thicker in the middle. Okay, and as you go to the edges, it becomes thinner. Right? So when you place an object, what is the image formed? You can see a real and an inverted image. A real, inverted and a diminished image. The closer the object comes to the lens, the bigger the image becomes. But at very close distance, okay, can you see the last picture over there? At very close distance, the image becomes a virtual image. Okay, instead of being a real inverted image, it becomes a virtual and erect image. So what are the convex lenses useful for? As I already told you, the convex lens converges the light. What happens to the light that passes through it? It tries to gather at one point. That is why we call these lenses as converging lenses. They are usually used in the magnifying glass. They are also used in all sorts of cameras, telescopes and microscopes to increase the size of the object. Then they are also used in spectacles to see very near things, as in reading glasses. If you're not able to read properly, so the doctor will prescribe you a convex lens depending on your power. Okay, so these are also made up of convex lenses. Now let us take the ray diagram of a concave lens. So look at what happens when the light from the object falls on the concave lens. It begins to diverge. It begins to spread out. And that is why we call this as the diverging lens. So concave lenses are called as diverging lenses. If you see the images formed by the concave lens, the image is always diminished, small, virtual and erect. So the images formed by a concave lenses are diminished, virtual and erect. That is why we can use the concave lens for spectacles for the nearsightedness. Suppose you want to see far off things, you are unable to see far off things, then you need a spectacle or glasses which are made up of a concave lens. This is the same reason why the concave lens is also used in the peepholes. Okay, there are small lenses fitted on your door to see who's come. Yes, those are called as the peepholes, and these are again made up of concave lenses. Right? So that's about the concave lenses and concave mirror. Coming back to the light. Have you seen the color of light? Can you say the color of light? No, light does not have any color. Or can we say that it is white in color? Yeah, we can say that it is white in color. Right? You have heard about Isaac Newton. Isaac Newton had this brilliant idea of passing white light through a transparent glass prism. Can you guess what happened? He got an image of a rainbow. Okay, all the 7 colors of rainbow he could see when he held a paper in front of the prism. So what happened to the white light? the white light split into its 7 colors when we passed it through a mirror. A prism. This is called as dispersion of light. And the band of 7 colors is called as a spectrum. So are there only 7 colors? No, actually there are more colors. But these 7 colors are the ones which we humans are able to see. Other animals and birds have the capability of seeing more colors, but we do not. We can see only these 7 colors. You have also seen the dispersion of light in nature. Yes, the second picture shows you the picture of a rainbow. A rainbow you can see in the sky just after you had a heavy rain followed by bright sunlight, isn't it? So, how do we get it? How do we get this dispersion of light? The thousands of tiny, tiny drops of water present in the air after a rainfall disperse this light and help in the formation of the rainbow. That is why you see a huge rainbow stretched out in the sky after a heavy rain, but immediately followed by the sunlight. That is another way of proving that yes, white light is indeed made up of 7 colors. Here we go the reverse method. This experiment was done first by Sir Isaac Newton, and hence the disk that he made is called appropriately the Newton's disk. So, what you have to do, you have to take a simple piece of cardboard, okay, say a 10 centimeter diameter of cardboard you take. So, you measure 5 centimeter radius in your compass, draw a circle, and what you get is a 10 centimeter of round cardboard. Okay, now divide this cardboard into 7 colors and you paint each of these 7 segments with one rainbow color, that is a vibgyu or violet, indigo, isn't it? So all these colors you paint, and what you have to do next, you have to make a hole in the center of the cardboard and make the disc rotate very fast. You can either do it with a hand with the help of a string, or you can use a electric motor also for this, right? So what happened when you move this disc at a very fast pace? You don't see the 7 colors. Instead, what you see is a white disc. Hence, Newton proved that when the 7 colors mix together, again you get a white light, right? So this is the story of the white light. White light is not just white light but made up of 7 visible colors. Okay, remember there are more colors which as humans you and I can't see. So here is an activity for you. You should make a Newton's disc whose method how to make everything I explained to you. Rotate with a high speed and show that the disc indeed turns white. Okay, you can record a video of it and send it to me to my personal number. Remember, this activity carries 10 marks. If you are unable to shoot a video, I want you to shoot some pictures and send it to me on my WhatsApp number. That's all for today. Remember, the activity carries 10 marks, and those who don't complete the activity won't get these marks. That's all for today. Bye bye for now.